Hi guys, I hope you are fine. Me too, I'm fine. So today guys, we are going to look at this question. And this question guys is mostly done by those who are doing computer or IT. So guys, we are going to attempt this question and find out how we can do the question. So guys, I can read the question, and the question is convert Roman 165 to base 10 to binary, and then this 1100 110101 to base 2 to denary. First of all guys, it's good to know that when we talk of binary, it is actually to base 2. So it's like we are converting this number to this format so that it will now have 2. Remember, in computers we only use 2 digits, and that's why it's called binary from the word binary. This one means 2 digits. Then we have also the denary, which also means the decimal numbers. Those are the decimal numbers we usually work with in other fields. And so guys, we are converting first of all Roman 1. We convert this number to binary. So what we do guys is that we come and write the number, that is 65. We go ahead and divide it by 2. So we divide it by 2, and then we shall be putting the remainder on this other side until we complete, whereby we cannot be able now to divide again. So our first division, and we do that using digit 2 because that is what we are converting this number to. So we divide this number by 2. When we divide that number, we will get that 2 remainder. Now this one will have a remainder 1, because this number, when you divide, if you are to multiply 2 times that 2, you get 64. So our remainder is 1. Come again and divide the 32, and then this one you will get now 16. So guys, here there is no remainder, and so you put 0. Again guys, you continue until where you are not able to divide again. Divide by 2, this one you are going to get 8. And so our remainder, still it is going to be 0. We continue again, you divide by 2, this one you get 4, and the remainder you get 0. Again guys, we divide by 2, this one you get 2, and the remainder is also 0. And then from there guys, you divide the last time now, divide by 2, this one you get 1, and the remainder is now 0. Once you do that guys, you now come and write your number here. This is your number, and this one is considered as MSB, which means is the most significant byte. And so we start with the most significant byte, and then we end up with the least significant byte. Maybe I can write here most significant byte, and this one is least significant byte. Guys, it's just like in numbers. If you have a number like, for example, maybe to show you an example, a number like, maybe a number like 1000, or a number like that. So that number, the most important number in that number is actually supposed to be 1. Because in case we change this one, for example, if I put 2 there, so that now it is 2220, and another person comes and changes this number, now changes this 0, so that is 1221. If you look at those numbers, numbers, you find that this has a very small change, while this one has a very big change, because this one you have added 1,000, or this one you have only added 1, and so therefore we call this number the most significant number, while this one now becomes the least significant. So even in computers, it has such kind of system, so that now the most significant byte now is going to be 1. So when we write it down, guys, we start with this 1, and then we can move up. So we have how many zeros here? 1, 2, 3, 4, 5. So I write 1, 2, 3, 4, 5, and then I write 1. So now this is our solution, guys, but now we have to put a 2 there. That is to show that this one is a binary number. So guys, thank you, and we now continue to Roman 2. For the Roman 2, we are given a number. Maybe I can write it down here once again. We have 1, 1, and then we have 0, 0, 1, 1, and then 0, 1, 0, 1, 0, 1, 0, 1, and then we have the base there. Guys, we want to convert this number to denary. Another name for denary is decimal number. And the decimal number is the one that has a base 10. So for this one, guys, what you normally do is that it's like now we are going the opposite way. Guys, you find this one we were dividing by 2. But for this one now, we will now be using 2 to multiply. But this one is different. So what we shall do, guys, we shall start off here, guys, by first of all we calculate this. How many numbers are these? We have, and we start with 0. Remember, in computer 0 is very important. So we start here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we reach there, we'll come and say, for this number, it is the digit number 9 starts for that. So we shall write now 1 multiplied by, and this one is this, 2 raised to 9, like that. We come to this other one. Here we shall write a plus. 1 multiplied by 2 raised now to 8, because that is the 8th number. Plus, we come now to the 7th number, which is 0. So we shall now write 0. This one was 1. This now is 0 multiplied by 2 raised to 7. 7 is its position, and that's what now raises to, now we say 2 to power 7. Then we go to this other 0. We shall have plus 0 multiplied by 2 raised now to 6. Remember, these ones represent the position, even though we are using them to raise 2. Then we come to, these are 2 zeros, then we have 1. This is the one we are talking about now. From here, it's supposed to be 0, 1, 2, 3, 4, 5. So we are going to have 2 raised to 5. Plus, we still have another one there, times 2 raised to 4. Then we come to 0. 0 times 2 raised to 3. We come now to 1 again, plus 1 times 2 raised to 2, like that. And then from there, we already dealt with this one. We are remaining with this 0 and this 1. So we go to 0. That is this 0 times 2 raised to 1, and finally plus 1 times 2 now raised to 0. So guys, we are now going to calculate that and see what we get. And so let's now look at that. So guys, for this one we are going to get 2 raised to 9. So let's calculate that and see what we get. That is, the first one will be 2 raised to 9. That gives us 512. So we write 512 there. We now go to this. This is plus 2 raised to 8. 2 raised to 8 gives us 256. This is 256. So when we come to this, guys, this is 0. If you multiply any number with 0, you get 0. So we can cancel this with zeros, because we will get 0 when we multiply any number with 0. So we are going to skip them. We now come to this. That is 2 raised to 5. 2 raised to 5 gives us 32. This is 30 plus 32. Then plus 2 raised to 4. That one gives us 16. And then we have 2 raised to 2. This one now gives us 4. 2 raised to 2. And finally, guys, we have plus 2 raised to 0 is supposed to be 1. So this one is 1. So now, guys, we add all those numbers. So that will be, let me just add here, 512 plus 256 plus 32 plus 16 plus 4 is 20 plus 1. So that gives us 821. So guys, our solution then is 821. And we can put a 10 here to show that this is a decimal number or a denary number. So guys, that is how now we do that problem. In fact, guys, you can go ahead and find the binary number of this and see whether it shall come to this. So if it comes to this, guys, it means you are now correct. So guys, thank you so much for listening to me, and may God bless you.